Hey, wait a minute. Have you ever wondered how we can store information by using fewer bits without losing anything? That is exactly Huffman coding does. Lossless compression, technically. That is a smart compression method. Give a short code word to frequent symbols and longer code to rare symbols. What do I say exactly? Let me see in the example. You have a source x1, x2, x3 until goes to infinity sometimes. But if you take the probability of all of these, this alphabet in our example is just a 6. A, B, C, D, E, F. When you calculate the probability of these 6 symbols, probability of A is 25%, probability of B is 35, probability of C is 5%, and D also is 20%, E 5%, and F, probability frequency in our source is 10%. Okay, if you're gonna exactly store this information without any compression, it's so simple. You have A, B, C, D, E, F, therefore 6 alphabet is between 2 power 2 and 2 power 3. Therefore, you need 3 bits per symbols. Okay, by this activity, you waste your memory. Why? Because all of this alphabet, they haven't equiprobability. But what is our reason? What is our solution? Yes, the powerful method, Huffman coding. Okay, let's explain you exactly the previous question, but in all of these probability, I just wrote in the order. For example, B, probability of B 35, A 25%, D 20%, F 10%, E 5%, and C also is 5%. But what is the strategy? At the first, you must produce the Huffman tree, and by Huffman tree, you obtain the code length. That is so simple. I show you step by step. For this strategy, at the first, you understood you must order all of this probability. I write from maximum to minimum. Okay, but in here, if you have a 2 minimum, you must merge these together. But I write the name of this, for example, 1, but another one 0. But when you merge these together, and that is exactly 10%, yes? Okay. Also, you achieve a one root. Okay, keep going. I started also by this 10%. I write the name of this 1. Also, the name, this branch is 0. But the sum of 10%, exactly 20%. But right now, what we must do? Yeah, we must merge these two values together. 20 and 20, I put the name 1 in here, 0 in here. That is 40. We add the probability of any branches. Okay, but in here, you see the 40% more than 25 and 35. What we must do? It's so simple. We must at the first write 40% and 10, 25%, and after that, I told you we must order all of this and 25%. But right now, we can merge these two values together. For example, I write for this, I don't know, 1, and for this 0, and if we add these to probability is 60%, and also we merge these, I write this 0, this 1, and we achieve 2 root, the top of the tree. Yes? Okay. Let's draw exactly step by this information our root. Okay, 0, 1. When we are in the 0, we have two values. 0, 1, exactly. 0, 1, exactly. This branch is 0. I branch again. 0, 1, that is B, and 0, 0, this branch goes to, yes, A. 0, 0 is A. Okay, but we are in the branch 1. You consider, okay, we came with this branch. 1, 0, 1, 0, what is the name? Yes, D, but another branch, 1, but right now we came to this branch. Right now, 1 also 0, we add the 0 and the name is F, okay, but also another branch we have. We are in the branch also 1, also 0 and 1. But when we are in the 1, What is the name? Yes, is E. What is the name of 0? C. Right now we obtain all of the code word titles. For example, 00, the name is A. 01, the name is B. 10 in here, the name is D. 110, the name is F. 1110, 1110, the name is C, and 41, the name is E. Okay, we obtain all of this code word. But in here, I gonna to tell you as more information theoretically. And what is the name of that? It's a Shannon theory. What is the Shannon theory? It says exactly. At the first, you must know what is the entropy. By our previous, if you're not master, please come back. Please come back to my previous sessions. You know that is pxi log pxi I from 1 to n. For example, n in here is 6. If we calculate this formula, we know all of our probability. For example, pa is 25, pb is 35, c is 5%, E is 5%, D 20%, F is 10%. If we put exactly in this formula, but it has a minus also, guys. If we put in here, for example, I put the B in here, 35 times log 35%, and also another one, 25 times log 25. And because we have a C and E, exactly the same probability, I put this in the same place, but times with 2, and also another one, 20% times log 20%, and the last probability of F, 10% times log 10%. That is so simple. If you use a calculator and you add all of these symbols and product by minus, in the last you obtain 2.26. That is your entropy for this source by this probability. But I'm gonna tell you another things, guys. What is the L in here? That is average of length, guys, because we hadn't the same length. Some of them they are 2, some of them they are 3, and some of them they are 4. But we're gonna to calculate the average length. Okay, it's so simple. It is, that formula is probability of any symbols times the length of that by obtaining the Huffman tree. For example, in here, we obtain the length of A 2, the length of B 2, and D also 2, C and E 4, and length of F 3. But if we put in this formula, therefore 35 times exactly I calculate in here, times 2 the length of that, 25 times 2 the length of that, also 20%, 20% is length of D times 2, and also the length of the F is 3 times 10%, and also 2 times, because C and E the length is 4, but the probability is 5%, therefore 2 times 5% and times 4. But if you also calculate all of these values by calculator, you achieve to this number 2.30. If you see, what is the name of this HX? What is the name of this L? The average length of the codes words. Okay, what is the important notice in here? Exactly this formula, that is Shannon theory for source coding, guys. What is the Shannon theory for source coding? That says if you have a lossless compression, that is just true for lossless compression, guys. You shouldn't lose anything. Always your average length is more than equal to entropy and is less than entropy plus 1. Okay? Entropy and entropy plus 1. Thank you for watching this video. Don't forget to subscribe me. If you had any question, please comment me, and take care. Bye bye.